Hi, in this video I'm going to provide a quick demonstration on how to build a multicast solution using NetEdit on Aruba 8325 CX switches. As we can see here in the screen, this is the topology that I have built out in my lab. It consists of a spine and leaf fabric, which consists of two racks. Each rack has two switches at the top of each rack, forming a VSX pair, and those switches connect to the attached host using multi-chassis link aggregation. And then, of course, these switches at each rack connect into the fabric using routed only ports, and we're leveraging OSPF as the interior gateway protocol to share the routes between the racks. And then we're also using iBGP, so the spines are actually set up as route reflectors in this BGP environment. And then, of course, rack 2 is actually acting as a border leaf, which is connected into another autonomous system. It's labeled L3 core here on the right, and we're using BGP to peer between these so we can share routes between these. Now what we want to do is we want to get this whole solution set up so that multicast traffic can actually transmit freely across the spine and leaf fabric, but also to the other autonomous system domain. In the environment that we have in the lab tested out, we have a multicast source, which is in rack 2, and that'll be sending 5 groups of multicast streams. And then we're going to have interested listeners that exist in rack 1, and we also have listeners that will exist in the different autonomous system in the L3 core. So we first want to get multicast working through the spine and leaf environment, and then we'll add it to the L3 core so that we can share multicast traffic between the different domains. So this is a view of the lab environment. In fact, these are the 3 hosts. So the one in the center is actually the sender that's trying to send multicast traffic in rack 2. It's sending traffic, but it's not going anywhere, as you can see, because in rack 1 on the left and L3 core on the right, they're not receiving any of that multicast traffic yet. So we want to make sure that we have green all the way across the board here so that all the devices here are receiving the traffic that they're interested in. Let's go ahead and jump into NetEdit. And I'm going to start by actually adding the multicast configuration onto the spine switches. So I'm going to choose the spine switches. I'll create a plan for that. And so the spine switches are IP forwarders in a spine and leaf fabric. So the spine switches are passing traffic between rack 1 and rack 2. So really what we want to do in this environment is we want to enable PIM, so protocol independent multicast, sparse mode. So what we do is we enable PIM. And then with 10.3, there's no PIM rendezvous point redundancy. So right now we're going to set spine 1, which uses its loopback of 1.1.1.1 as the rendezvous point within the spine and leaf environment. So now that PIM has been enabled, really what we want to do is just go to the interfaces that we need this enabled on and enable PIM sparse mode. So we're going to go to the 4 downlink interfaces that connect to all of the leafs. We'll enable IP PIM sparse, and then we'll go to the loopback also, since we're leveraging that in this environment. Okay, so now that the config is in there, let's go ahead and click on validate to make sure that I didn't make any mistakes. Everything looks good, so let's go ahead and return to the plan, and we're going to go ahead and deploy this plan. We'll take a look at some of the change validations when they come up. So now we can look at the change validations, and we can take a quick look at, let's say, the PIM configuration. This is spine 2 we're looking at. We can see PIM is now enabled. We can see the interfaces that it's been enabled on. There are no neighbors right now, right? Because we haven't configured the leafs yet. So let's go ahead and finish this config. We'll finish this config by committing it out. And then we'll start a new plan where we'll start configuring the leaf switches. So let's go select those 4 leaf switches. We'll edit their config. Now let's start on the leaf switches by doing the same thing. Let's get PIM enabled and then PIM added to the interfaces that PIM needs to be on. So we'll router PIM. We'll enable it just like we did on the spines. And then of course we'll tell all the leaf switches that spine 1 is going to be the rendezvous point in this spine and leaf environment. Okay, so now we can just start adding the, oh, I'm sorry, the active command, right. We need to add the active command. This is a VSX pair, and the active command actually helps the VSX pair in case one of the switches goes down. So within a VSX environment, one of the switches is going to be the active IGMP forwarder for traffic within that VLAN segment, and active allows faster failover between those segments. So I'm going to go up to the fabric-facing interfaces and enable PIM sparse. Then I'll do that on the loopbacks. Okay, now I'm going to start configuring the host-facing configurations. So these are the VLAN configurations and the MLAG on the MLAGs facing the servers. So rack 1 uses VLAN 10. So I've deselected the switches in rack 2, so we're only working on the switches in rack 1. I've added VLAN 10, and of course this is where we're going to add the IGMP snooping command. So IGMP snooping's been enabled on VLAN 10 now. Now let's go down to the VLAN interface. And at the interface level, this is where we're going to do the basic IGMP enable command, as well as the PIM sparse command. So let's enable both those on the actual VLAN interface. And now we're going to do the same thing except for rack 2. So rack 2 uses different VLANs. In this example, it's using VLAN 11, but we're going to do the same thing. So within the VLAN 11 context, we'll enable IGMP snooping. And then within the VLAN interface context, we'll enable IGMP as well as PIM. And we do have an interface from this rack 2 because it's acting as a border leaf facing the L3 core. That's a routed interface, and so while I'm here, I might as well enable PIM sparse on that interface too. Okay, so we've got the multicast configuration added to rack 2 now. Let's go ahead and validate this configuration to make sure there's no mistakes in the configuration. Okay, everything looks good, so I'm going to go ahead and deploy this out to the leaf switches. Now, if we take a look at those multicast hosts, we can see the host in rack 2 is streaming that multicast traffic. Rack 1 hasn't started receiving it yet. And there it goes. So rack 1 is actually starting to receive that multicast traffic. So we have all green within the spine and leaf environment. So the spine and leaf environment with the multicast is all complete and set up now. If we look at the L3 core though, let's look at change validation. So when we pull up the change validation screens, obviously we can do show IGMP. So IGMP is enabled on that switch. We can do, of course, the PIM interface commands and the PIM commands to make sure PIM is up. Now we should have some neighbors, right? Because the leaves are configured and now the spines are neighbors. Go down to rack 1 and I can see rack 1 with listeners is actually seeing the querier and seeing the multicast groups within that. The show IPMG groups command is also showing us a bit more information about the IGMP groups being seen within this VLAN on this switch. The last reporter, the IGMP group, how long it's been seen. And then of course the show IP multicast route command is showing us the traffic coming in on which interface. We can see rack 2 is showing the multicast routes. Okay, so now that multicast is working in the spine and leaf environment, I'm going to go ahead and commit this configuration. Now, if we look at the L3 core, we'll see that the L3 core still isn't receiving that multicast traffic. So we still need one more final config. We need to get the PIM information within these two domains shared between these two domains. So to do that, let's start the final config. And for this one, we're just going to choose the L3 core, and then we're just going to choose spine 1. So we'll edit the running config on these, and this will be the final multicast config. So to start this one off, I'm going to start by configuring the L3 core. So let's deselect spine 1. And then we'll start the multicast config just like we did on the other ones by enabling PIM. Now this is a different domain, and so this switch is actually the rendezvous point in this domain. So we're going to use this switch's address as the rendezvous point for that domain, 1.1.1.7. And now what we also want to do is enable router MSDP. So this is what will help share this PIM information between the two domains. We're going to enable that, and this is where we're going to add the MSDP peer command, and we're going to be pointing to the spine 1. Go ahead and loop that through the connect source loopback 0 command, and we'll enable that also. So now that PIM is enabled, just like we did on the other screens, we want to make sure that PIM sparse isn't enabled on all the interfaces that it's required on. So remember, that's the VLAN interface. Of course, at the VLAN interface, we'll also enable IGMP. Oh, I shouldn't have hit backspace there. Let me fix that. So while we're doing that IGMP, let's just get the VLAN created, and we'll add IGMP snooping to that. And then, of course, the PIM sparse finally on our fabric facing interfaces and loopback. Okay, so now let's just go add the final configuration onto that spine switch. So remember, the spine switch was fully configured for the spine and leaf environment, but now to complete this configuration, we just want to add the MSDP configuration on this spine 1 switch. And kind of opposite we did on the other switch, we're going to enable it, but of course the peer in this case is going to be the switch in the other domain, so 1.1.1.7. Again, we're sourcing it through the loopback, so we need to put that command in there and enable it. Okay, so now let's check validate, make sure these configurations is accurate. Okay, everything is looking good, so let's go ahead and deploy this config. Let's pull up the multicast streams for these two groups. Give the switches a chance to throw out the config. Okay, we can see the two groups already starting, being seen in the other domain. Let's give it a couple more seconds, and there the other groups are. So now we've got multicast traffic being streamed within the spine and leaf environment, and of course also to the other BGP autonomous system number. So now that the config is good, I'll go ahead and commit the config and write it to the startup config, and we'll be good to go.